Hello everyone. Today we're going to continue a lesson with limits. I know that you thought that we were done with limits, but nope, it keeps recurring during our course of calculus, okay? Now, this is 8.7, so we're skipping a little bit, okay? We're jumping to it because it's relevant, and it's going to make your life so much easier. So please take notes and follow along. A, what is an indeterminate form? I know you've seen these before, and trust me, you'll be reminded, okay, throughout this lesson. How do you find limits for indeterminate forms? How do you use the L'Hopital's rule? You're going to love this rule, okay? To find limits. Here we go. To find limits, we use these techniques, right? We know the three techniques. We use direct substitution when we can, analytically, and graphing, which involve both, right? Like if you graph it on a calculator, you have to do some analytics, right? So, now, but how about those weird cases, right? How about your ooh, like 0 over 0, or your positive negative infinity over positive negative infinities, right? These are called the indeterminate forms, and these are the only cases that you're allowed to use L'Hopital's rule. So let's just write that right now, okay? It's eligible for L'Hopital's. It's eligible for L'Hopital's, okay? These only cases, ooh, or like 2 8s upside down, okay? 2 8s, I guess, knocked over, okay? So infinity over infinity, positive or negative on both cases. Okay, now, these are called indeterminate forms. Example, like you've seen these cases before. For example, when I plug in 4 here, it becomes 0 over 0. Ooh. Now here, it becomes what? Right? So these are indeterminate forms. You can't just do direct substitution. All right? So I'm going to change the page, and we're going to go through some examples, case by case. So let's take a look, okay? Oh, I'm just going to, actually, let's just skip over that, okay? Actually, let me just go over this with you. Of course, you know that these are all indeterminate forms too, because in the end, when you get this, right, when you get like this, right, you're like, how do I conclude? I'm going to give you some values later. I'm going to give you some scenarios later. And plus, in Calc AB, you don't have to know every single case. But for now, we'll discuss some indeterminate forms that we're going to talk about, okay? Now, all these are indeterminate forms, and I'll show you how to conclude those later in a sec. Now, let's think about what we know already, okay? What do we already know? We already know how to deal with cases like this, right? We're like, oh, find the limit. Let's do that. Let's find the limit. Go ahead and find the limit of this. Do you remember how to do it? I hope so. So you would rewrite this, right? Limit. You can't do direct substitution because what's going to happen? 0 over 0. No good. So no direct substitution. So 0, 0, you can't, right? Ooh, okay. But you don't need L'Hopital's. You don't even know what that is yet, maybe. You don't need L'Hopital's because in this case, you can actually simplify, right? This is called the dividing out method. Do you guys remember that? I hope so. And haya, then you're left with limit of x approaches 2 is going to be 1 over x plus 2. Now you would direct substitute, right? Then you get the answer as 1 over 4. I'm sure you already got that, okay? So now, these are the cases that you don't need anything fancy. You just do your algebra, right? Okay, now let's go here. Definition of L'Hopital's rule. If f and g are 2 differentiable functions, and if limit of x approaches c is f of x over g of x, okay, and they're both differentiable, produces an indeterminate form of 0 over 0, 0 over 0, or infinity over infinity, then the limit as x approaches c of f of x over g of x is equal to limit of x approaches c, f prime of x over g prime of x. So simply taking the derivative of both top and the bottom, it'll produce you the limit, okay? And that's the L'Hopital's rule. Again, in our class, we're just going to discuss the simple cases, okay? So let's try one together, and I've broken it down by scenario, each case. All right, so here we go. Let's do example 1 together. It's an indeterminate form of your classic ooh, okay? Ooh. Can you see that? All right, ooh. So what do we do here, okay? Now let's first try, okay? Is it eligible for the L'Hopital's, okay? L'Hopital's. Is it? Let's check, okay? When you plug in 0, 0, you get 0 over 0. Because e to the 0 is 1, 1 minus 1 is 1, 0, and over x, 0. So it's eligible for L'Hopital's. Yes. So now let's take the limit. Limit, x approaches 0. Now, L'Hopital says you got to take the derivative of both top and the denominator. So go ahead and do that, guys. Again, this step right here, if you don't want to, you don't have to show the d over dx if you don't want to, okay? Now, I'm sure you found the limit, you found the derivative. Go ahead and write it. Check back with me later. Over 1. Now, if you plug in the 0, now direct substitution. So I'm going to justify, like a little proof, okay? L'Hopital's here, direct substitution, and then what do you end up with? You get big ol' 2. That's the limit. If you don't believe me, go ahead and check on your calculator, okay? All right. So again, L'Hopital's make it so easy, okay? Let's do this one. Indeterminate form of infinity over infinity. Well, let's first always check to see if the limit of x approaches infinity, natural log x over x does produce infinity over infinity, okay? Because we have to see if it's eligible for the L'Hopital's rule. If we plug in infinity over infinity, but don't remember, infinity just means a huge number. Natural log of a huge number, it can produce a value. Natural log of an x, a huge number, so that means this guy is infinity over infinity for sure. So it's eligible. Now go ahead and take let's use L'Hopital's now. Okay, L'Hopital's, okay? Let's do d over dx, natural log of x, right? Over d over dx, just to x. Then what do you get when you, don't forget the natural log, don't forget the derivative of natural log, which will give you 1 over x over 1, and which also gives you 0. I hope you understand why. It's because this guy is really simply 1 over x, right? So as x gets really, really large, it becomes 0. So your limit is 0. Okay? L'Hopital's makes it so easy, okay? You're like, why didn't you tell me this before? I know, okay? I hold a lot of secrets. Example 3, applying L'Hopital's rule more than once. You're right, sometimes you're going to have to use it twice or even 3 times until it's possible for you to make a determination of a limit. So evaluate limit as x approaches negative infinity, x squared over e to the negative x. E to the negative x. Now, let's check to see if it's eligible for L'Hopital's rule. If it gets really, really large, negative infinity-wise, you'll get something like this, right? Negative squared is going to be a positive. And then this guy here, e to the negative of a negative, so it's going to become a positive infinity. So it's eligible for L'Hopital's rule. So what are you going to do? You're going to take L'Hopital's, right? So I will stop writing d over dx, okay? What's the derivative of this guy? X squared, it's going to be, yep. And this guy right here, it's going to be negative e to the negative x, okay? But now, let's try kind of like direct substituting negative infinity here. You're right. It produces, again, negative infinity over negative infinity. So that means you can't determine anything. It's still indeterminate. Therefore, you have to use L'Hopital's again. So L'Hopital's, right? Okay, again. Do it again. Do it again. So let's take limit as x approaches negative infinity and take the derivative of 2x. So you get 2. And again here, so you get e to the negative x. Now, can we actually make a determination of a limit? If I plug in like huge negative number, what would I get? This stays constant, right? What happens to this sucker? What happens to this guy? He becomes a huge number. This becomes a big number. As it's a negative infinity, so e to the positive infinity, really, right? So it becomes 0. There's 2, which stays constant, over a large number. So the limit is 0. Okay? Okay, let's go over a couple things. Before we move on, I would like to give you some special cases, okay? Some specials include this. You don't have to explain, you don't have to know, actually, yeah, let me just show you, okay? Special cases. You don't have to memorize these or anything, but it's good to recognize, because, you can derive these too. X times 1 over x, I'm going to tell you it's 1, okay? Okay? These are special cases. Limit as x approaches 0 of x. What do you think this guy is then? I hope you guessed 2. Yay, okay? Limit as x approaches 0 of x over 1 over e to the x. What do you think this guy is? Think about it for a second, okay? And it's 0. Limit as x approaches I meant infinity here. Sorry, infinity, okay? Limit as x approaches infinity for e to the x over 1 over x. Now, I'm going fast, but try to digest it as I'm going over it. plug in some values. Try some numbers, okay? E to the x over 1 over x is going to be infinity. These are some special cases. Okay, write these down. Okay, now I'm going to give you guys one more example, and then we're done. And then a few more special cases. One more example, okay? Now, what happens when you have this? Put this away. Stop the video anytime. Let's do example 4. Indeterminate form of 0 times positive infinity. What does that mean? That means when you take a large number, because limit is as approaches positive infinity, so if you take e to the large number, but it's negative, right? That means you're really going to get something like 0. And what's square root of a large number? It's going to be infinity, right? Then it's indeterminate also. So you're going to take L'Hopital's rule here. So let's go ahead and apply the L'Hopital's rule so they differentiate both. But before we do that, let's rewrite this so we can actually, differentiate easier for us, okay? So go ahead and differentiate that, guys, and see what you get. See if you get something like this. Yeah? Okay, hope you're differentiating correctly. Now let's go over here. So limit as x approaches positive infinity. Let's rewrite that so it's friendly for us to determine, okay? Isn't this really just 2 to the square root of x times e to the x? Now, is it going to give us any problems? So let's take a huge number, 2 times a huge number, and times that by e to the huge number, which is going to approach, you got it, 0, okay? So that's going to be 0, all right? So I'll try, I think that's good enough, and let me sum it up for you, okay? So I just want to sum it up. These are really good to know. What about these cases, okay? Are they indeterminate, or do they have some sort of value, okay? Positive infinity plus positive infinity, it goes to positive infinity. That's common sense, right? Because limits is positive infinity, because you're adding more and more infinity, right? How about here? Negative infinity minus infinity. It's going to become more and more negative, okay? So limit is negative infinity. How about 0 to infinity? That's going to be 0, right? Because you keep on powering 0. It's going to be 0. Now, this one's a little tricky one. Okay, I'm going to cover this up a little bit. Okay? 0 to negative infinity. 0 to negative infinity, okay? Think about this. Remember, it's not really 0 here, right? Because you're wondering, why is this infinity? Remember, this is some value that's really close to 0. So really, if you rewrite this guy, isn't this really 1 over a small number that's really close to 0? I'm going to write a fuzzy 0 because it's not really 0. It's a number that's really small. That means it's going to be like that. What's 1 over a really small number? That's going to be infinity. That's why it's positive infinity. So this one's a little bit strange, but it makes total sense. Because remember, we're always taking limits as approaches 0. It's not really 0. We're never taking about infinity. We're talking about a large number as it approaches infinity, okay? How about this one? I want you to see if this is okay. Is anything wrong with this guy right here? Is something wrong? Is this totally valid? Think about it. So, I hope you made the conclusion that it's not okay. Why is it not okay? So what happened from here to here? If you're thinking L'Hopital's, you're right. They did L'Hopital's here. But what do we have to always check for before you do any L'Hopital's? You got to be like, okay, is it eligible for L'Hopital's? Let's try, okay? If I plug in a 0 here, I get e to the 0. If I plug in a 0 here, I get 0. Is this a ooh or a this case? No, it's not. So it's ineligible, okay? So remember, the hypothesis has not been satisfied for L'Hopital's. So you can't just go ahead and do that, okay? So it's not okay. All right? Remember, the first thing you have to do is always check to see if L'Hopital's is even eligible for you to use L'Hopital's rule, okay? So you guys, good luck with your homework, okay? And try your best.